nonprofit, and the HeatSmart CNY is a project of AGREE and the Central New York Regional Planning and Development Board. We are funded by NYSERDA, and we are one of 19 clean heating and cooling communities around the state. So I'd like to start by acknowledging that we are on the unceded land of the Onondaga Nation, where we're broadcasting from, and give them a lot of respect because they're the ones that taught me the first. There's the first example I saw of a geothermal building. Their fire barn, when they designed it earlier, about 6 years ago, they designed to be fully geothermal, heated and cooled, and powered with solar panels. To date, we've had over 1,500 people engage with us in events. We've had over 150 events, both tabling, workshops, open houses, and 185 homes have been improved through this program at this point. Collectively, we have reduced the carbon emissions by 2,500 tons of carbon dioxide each year. This is a map of the other clean heating and cooling communities across New York State. In case you're joining us from outside of the Central New York region, we work in Onondaga, Cayuga, Cortland, and Madison, and Oswego counties. You can see some of the other campaigns here. Feel free to look them up, or if you need to, I can help you connect with them. So today we're going to talk about heat pumps. We're going to talk about why we're talking about heat pumps. We're going to talk about what they are, how they work, how to make our homes heat pump ready, the incentives and financing, and we'll have our installers joining us later on to help with questions and answers. So the number one reason why we're doing this is because of climate change. We are running out of time to actually make a difference. And the most recent report of the United Nations said that we need to basically be eliminating our fossil fuel emissions by 2050 at this point. The longer we wait, the harder it becomes, and to keep things below 2 degrees Celsius warming in this century. One of the things that we are doing, in New York State, we're actually leading the way to address this. And New York State law at this point is to get to a 85% reduction in emissions below 1990 levels by 2050. We're looking at a 40% reduction by emissions by 2030, having 100% zero carbon electricity by 2040. A number of other goals and targets. One of the other key ones there is the 185 trillion BTUs saved of on-site energy savings by 2025. And that's because buildings are 30% of the greenhouse gas emissions in New York State. It's our homes, it's our residences, it's our workplaces. All of it adds up. And so we have the hard job of trying to switch houses house by house. The good news is that there's a number of really good benefits to doing heat pumps, and that's why we're telling people about this technology. It hasn't been well known in Central New York. People who've heard of heat pumps have maybe heard of them down south. The good news is they do now work in our climate area. So with heat pumps, we can heat our buildings without the pollution, fumes, and expense of fossil fuels. We can add cooling. Heat pumps both heat and cool, so that helps us adapt to hotter summers. We can power it all with renewable energy and dramatically reduce our carbon emissions. In addition, there's a lot of other benefits for going with heat pumps, which is why a lot of people choose heat pumps. One of the main ones is energy costs. We're looking at decreased energy costs, especially for households using oil and propane or baseboard electric, especially after this past year. People who switch to heat pumps from those fuels usually cut their energy bills in half or more. People on natural gas, natural gas is still one of the cheaper fuels. And so if people are switching to geothermal, they cut their energy costs. If they're switching to air source heat pumps, it usually about equals out. You end up with a higher electrical bill, but you end up eliminating the gas bill.
And electric defrost, probably.
Can everyone remember to mute, please?
Mute. What?
Okay. Oops. Go back for a second. It also increases home comfort. A lot of us have heating systems that have been pieced together over time in our older houses. The way the heat pumps work is with variable speed blower fans and variable amounts of heat with inverter technology. And so it means that it's actually putting the amount of heat into your house that you actually need. Instead of our old furnaces, it was either all on full blast and then it waits for it to decrease and it's all on full blast again. So we have temperature fluctuations in our homes. This allows for a very even constant temperature. It can allow for different zoning and allows for very efficient cooling, particularly with geothermal. And of course, with no combustion in the houses, you also have no carbon monoxide emissions from that heating source and other air pollutants that are in the homes. There's increasing studies coming out showing the impact of burning natural gas in the homes. There can also be advanced air filtration through these. So we're also reducing other pollutants in the atmosphere and also in the disadvantaged communities where we have a lot of the power, in the fossil fuel manufacturing facilities. And then it also allows for you to power your heat pumps with, say, on-site solar photovoltaics. And even if you're not doing solar panels on your house, the grid in upstate New York is extremely green. We have over half of our electricity already coming from renewable energy. So how do heat pumps work? The reason why they're so efficient is because they're not just creating the energy strictly from, creating the heat strictly from the energy that you're burning. With fossil fuels, you're clearly burning. With electric, you can consider baseboard electric as basically burning electrons. The way that heat pumps work is they're actually capturing energy that's in the environment around us. It can be from the ground, or it can be from the air, or it can be from water sources. We don't cover those as much here, but if you do have a pond on your property, it may be a source that you can use. So ground loops, they go into the ground. Ground temperatures an average 40 to 50 degrees. So you're already pulling from that temperature. You bring it into a heat exchanger. It goes through basically a reverse refrigeration loop, compresses the heat. What happens when you compress something to become gas and make it back into a liquid? You heat it up. And then that becomes the heat that's used inside the house through whatever distribution system you have. It can be radiant heat, it can be forced air. Air source heat pumps, same concept in terms of the heat pump technology, but you are capturing the energy in the air around us. Now, even when it's really cold outside, there's still energy. The only time you don't have that is if you're at 0 degrees Kelvin, which is 273 degrees below 0 Celsius. It does not get that cold in central New York, but by a long shot. They do lose some efficiency as it gets colder, but all the ones that are called cold climate air source heat pumps are still putting out twice the amount of heat that you would with the same amount of electricity from a electric system at 5 degrees Fahrenheit. And a lot of them work down to like 13 degrees below 0 Fahrenheit. So here's some examples of what they look like. These are air source heat pumps. You can see outside, they look like air conditioners. People have seen these before. Inside, it can be wall-mounted units like this. These are called ductless mini splits. You can have high wall units. You can have low wall units. You can have some in ceiling panels also. You can also have them go into your ductwork. So there's a lot of options for the actual distribution in the house and how they pair up. Here's some other ones with the indoor units. You can see where some of them are. And I want to get technical for a brief moment. So the importance of cold climate air source heat pumps cannot be emphasized enough. There's lots of heat pumps on the market, and a lot of them are designed to work, say, down south, where it doesn't get below freezing very often. The ones that are designed for down south, they start to cry when it gets below freezing. The cold climate air source heat pumps are designed for our climate. They're being installed across Maine, Vermont, Massachusetts, Canada, Norway, and we're doing it across New York State here too. One of the things to look at when you have a proposal is to look at the NEEP list. It's Northeast Energy Efficiency Partnerships. if you just look up NEEP and air source heat pumps, you'll come to their list. They have listings of all the different cold climate air source heat pumps. This is the master list that NYSERDA references. And it has the technical details there. So one thing you can look at is how much heat is it putting out at various temperatures. And you're looking at the coefficient of performance here, which as well as the BTU hours. This is the heat that's putting out. You can see the coefficient of performance, which is basically how energy efficient is it at a given temperature. With the higher number being more efficient, a resistance electric unit would be 1. A coefficient of performance of 1. 1 kilowatt hour of energy becomes 1 unit of heat. You can see that even at 5 degrees, cold climate air source heat pumps, this is a common unit that's installed through some of our installers, it's putting out 2.5 times the amount of energy. So it's really efficient. Another option that people who are on gas can look at if they're not willing to do a whole home transition is to do a hybrid system. And so it's basically pairing a cold climate air source heat pump with a gas furnace. And that allows people to choose the temperature at which they switch over to using the air source heat pump. You get the most out of it if you're using the air source heat pump down, well below zero, just below freezing rather. But around like the teens, people tend to switch over. You make the choice based on, how much greenhouse gases you want to save and energy costs at a given moment. Ground source heat pumps, again, are the most efficient, where air source heat pumps range in like the 2 to 4% efficiency, with 2 to 4 times efficient with coefficient of performance. Ground source heat pumps range in like the 5 times more efficient. It can even be more than that. The key is that you have to have a fair amount of surface area exchanging with the ground. You can do this 2 ways. You can have a vertical loop field. The wells go down up to 500 feet. Sometimes houses need multiple wells depending on the size of the house and the amount of heat that it needs. Or you can have horizontal loop fields if you have a lot of land. One thing that we're finding is that if people do have the land, you'll probably see your system installed faster if you do a horizontal system. The drillers are in high demand. So here's a number of homes. All of these are geothermal. These are the ones that have really cut their energy costs down to almost nothing, pairing geothermal with solar on their property. This one in your upper right-hand corner, the old farmhouse, that's 200 years old. It was originally heated with wood. It went through a lot of different kinds of heating fuels. They pay $20 a month for their entire energy costs at this point, just the electric connection to the grid. And a number of these also are very close or have gotten there already. It can also be used for very large buildings. The town of Hamilton Highway Department is heated with geothermal heat pumps. Food Bank of Central New York's warehouse is heated and cooled with geothermal. The Marcellus Library, the Pike Block in downtown Syracuse, they drilled those wells right through the sidewalk, as well as the Shinneman Science Center at SUNY Oswego, which is a massive building. I want to do a quick case study on geothermal. This is a house in Manlius that did a big update. They were built in the 1960s. It's a 200 square foot house. They ended up having 2 wells at 250 feet deep due to the local geology. And just to give you a sense, geothermal coming in, it is going to be a disruption to your property. The good news is once it's in, there's nothing to say it was there once the grass grows back. So, leveling and reseeding the land is an important piece. But once it grows back, you can't tell, there's no outside equipment. Their system was a Geostar. They had what they call the Sycamore added to it, which is tracks the energy use and allows them to see in real time how much they're using. You can see this is the fluctuation. The orange is the heating load. The blue is the cooling load. Total through the year, they used 3,400 kilowatt hours to heat their house. The total for heating and cooling was only $540 the whole year. Consider your own heating and cooling bills. Think of how it compares. Comparing apples to apples with a geothermal, before they were using 893 therms of gas. Afterwards, 0 therms of gas, they're using 3,400 kilowatt hours to heat. Before they were paying about $1,000 to heat with a gas for the year. And afterwards, they're paying $340 for the heating. And you can see the carbon emissions decrease significantly. 4.7 tons carbon dioxide emitted versus 0.5 tons. This was looking at all the overall energy use in the whole house. So you can see it really does make a dramatic overall difference in the whole home heating load and energy load. One of the other technologies are heat pump water heaters. We're seeing these installed in a lot of homes. They basically pull on some of the air from around them in the basement to take heat and pump up that temperature into the water. So they are 2.5 times efficient generally from, certainly from electric water heaters. And they do have cost savings over gas water heaters too. They can have multiple modes. You can have it on straight electric. If you've got a lot of people coming, you got to just have a lot of hot water. But yeah, it basically just pulls from the environment around it. A couple of things with heat pump water heaters. If you have a finished basement, it's probably not a good fit. It does decrease the temperature around 10 degrees or so. If you have your water heater in a closet, that's also not a good fit because you do need airflow. It needs to actually have air coming through it to get the heat from the air. So just a comparison, again, energy efficiency, looking at, if you consider baseboard electric 100% efficient, air source heat pumps are 2.5 times more efficient on average. Geothermal are 4 times more efficient on average. Ductless mini splits can be complete in themselves. They can replace any heating system. There are ductless or ducted versions of air source heat pumps as well. Geothermal heat pumps do require some existing distribution system, whether it can be to ductwork or it can be to hydronics. You may need to add additional surface area for the hydronic radiant heating. Air conditioning, you always have that with cold climate air source heat pumps. With forced air systems and geothermal, absolutely you get the air conditioning. If you have a hydronic system, you will need to add some air handlers to give some air distribution for the air conditioning. You can see the zoning. Average lifespan, air source heat pumps have a shorter lifespan because they do have the equipment outside. All of us are using, we in Central New York, I know, tend to keep our heating systems going a lot longer than their estimated lifespan. The 15 years is what the manufacturers estimate for the lifespan of the average furnace at this point. So just to give you a comparison, a lot of people push that way past then. With geothermal, that ground loop, once it's in the ground, is good for 50 years or more, as long as you don't dig it up with a backhoe. So do know where it is and tell whoever buys your house next. And the indoor unit, because it does not expose to the air around it, it's around 25 years is the life expectancy. Air source heat pumps can be impacted by deep snow or wind. It's useful to put them where it's less windy around your house. So telling the contractors, what side gets the most wind is a very useful thing to do, as well as avoiding places where the snow might blow and drift and pile. In a 10-foot blizzard, you may need to dig them out. Only a Oswego really needs to worry about that. They are up on stands, so most snowfall, it's not ever an issue. Again, with the air source heat pumps, the disturbance to the property is minimal. With geothermal, it's pretty extensive, but it is a one-time event. The average cost of the systems with air source heat pumps, we're seeing the average cost come in around $20,000, and there's a bunch of rebates available. With geothermal systems, it's coming around $40,000. And again, there's a lot of rebates available. It all depends on the size of the house, how leaky your house is. And the next thing we're going to talk about is making your home heat pump ready. Well, not quite yet. So this is just comparing energy costs. So you can see the green down here is geothermal, the cost per unit of energy provided. The blue is natural gas, red is oil, and black is propane. And you can see that, first of all, geothermal comes in a lot lower in terms of operating costs. It also it doesn't spike nearly as much over time, so it helps control your energy costs. And then the air source heat pump, it's not on this, but it comes in around somewhere midway on that, on the blue lines, only it's basically take the geothermal and put it out there in terms of the fluctuation cost. So how do we make our homes heat pump ready? One of the important things about heat pumps is that they are not putting out the same massive blast of hot air. And so if your house is particularly leaky, you may not be comfortable. The key here is making sure you have good insulation. And no matter what heating system you have, improving the insulation is going to save you energy, it's going to save you money. So often we start with this in the presentation. I want to come to this and actually emphasize it at this point, because it's how we make the homes ready. Your attic is one of the key places to add more insulation. Think of it as the hat on the human being. You also want to have boots on your feet when you're to stay warm. Well, the basements are also a key place of indoor air infiltration. You can see it coming in from what they call the rim joists, the space between the foundation and the first floor. It's a very common place that's uninsulated, and insulating that can make a big difference. And one of the things you can do is, once you close up those areas, insulate the basement, insulate the attic, and insulate, you basically air seal around openings. You can see recessed lights, bathroom fan vents, attic hatches, things like that are often sources of places where the heat escapes. Good air sealing can make a huge difference there. Once you keep the heat from escaping, you also keep it from then pulling in from the bottom. So it keeps your house a lot warmer. So how do you improve the insulation in your house? The contractors that we work with, they all do energy audits. So they can come with this really cool technology. They can come with infrared cameras. They also do a blower door test. This is what a blower door looks like here. It basically does a brief, it briefly creates a bit of a vacuum on the house, and they can measure how much air is coming in to your house doing that. And that gives them the numbers that they need to design the heating systems well and design how much insulation needs to go in. Energy audits always start with a discussion of your own goals and, discussing what might be some of the problem areas in your house too. Are there places that have extra moisture? Home performance contractors look at not just the energy, but they look at the whole home as a system. And that's really important. And with an energy audit, again, the contractors can make proposals for your house. Here's some examples of different kinds of insulation. You have spray foam going on the roof of the attic. You can have cellulose, on the top, on the floor of the attic. A lot of the rim joists are often done with spray foam, and those are really good. So let's talk about the financials at this point. I want everyone to take a look at this chart, find your household size, and take a look and see if you fall into the Empower or the assisted home performance categories. 60% area, below 60% of area median income, or below 80% of area median income. Keep which category you fall into in mind as we talk about the next few slides. So for insulation work, energy efficiency work, and this can now include heat pumps, for people who are low income at 60% of median income or lower, there's a $10,000 grant through New York State for insulation and energy efficiency work. It's basically, this work gets done at no cost to the homeowner. So it's a huge benefit for people who are already struggling with their energy bills. There's currently some additional funding for people who are heat recipients this year. It is rapidly running out of time to take advantage of that, though. So if you are a HEAP recipient and want to explore that, I encourage you to enroll tonight. The system has to be installed this summer in order to use that money. There may be additional funding in the future, so we will be alerting people if there is a change. For assistant home performance, below 80% of area median income, there's a $5,000 matching grant from the state. So if the homeowner puts up $5,000, the state chips in $5,000 towards the cost of the systems or the cost of the installation. The other thing to know is that Empower actually can be used for rental properties also. So renters, if they're Empower qualified, as long as the landlord signs off on it, they can have installation approved. For market rate customers, everyone above 80% of area median income, there's the Comfort Home program. It ranges between $500 to $4,000 in terms of the grants available. It depends on the amount of work that you're doing for the insulation in your house. For the heat pumps, there's a whole other chunk of funding available. So there are the utility rebates. It's called the New York State Clean Heat Rebate. For cold climate air source heat pumps, you're looking at currently a per 10,000 BTU hour incentive. For cold climate air source heat pumps, it's $1,000. For ground source heat pumps, it's $1,500. With cold climate air source heat pumps, we're seeing rebates around $2,000 to $5,000. With ground source heat pumps, $2,000 to $8,000 is a rebate. Heat pump water heaters have a rebate of $700. And if you're looking at a large commercial project, there is also incentives available for that too. At the federal tax credit level, there's currently no incentive for cold climate air source heat pumps. It's the one we had expired at the end of last year. There may be another one. We'll wait and see if anything passes through Congress. With ground source heat pumps, there's a 26% federal tax credit with no limit to it through the end of this year. Next year, it becomes a 21% tax credit. Again, the heat pump water heater credit ended also. But now, new as of last month, New York State has given a ground source heat pump tax credit also of 25% of the project up to $5,000. So you can only take $5,000 as your tax credit. And that's only for residential properties. And you have to be with one of the major utilities to take advantage of most of these, or of the utility rebates, that is. If you're on a municipal or rural cooperative electric utility, they don't pay the systems benefit charge, they don't get the funding. But if you are a HEAP recipient, those grants are available because it's a federal program. I want to give you some examples of how this works out. So for that house in Manlius we're talking about, the initial cost of the geothermal system was quite high, actually. It was $65,000. From that, they deducted $10,000 with an NYSERDA incentive at the time. That would have been the higher end of the geothermal incentives that we're seeing currently for the utilities. And then they had a 30% federal tax credit. So that was $16,000 off the cost. So their final cost was $40,000 roughly. And of course, they also did solar panels at the same time. And you can see that those also come in. And you can see the tax credit here for the state, how that applied. You would also see that on the ground source heat pumps now. This is another geothermal system. This is out in Jamesville, and you can see the total cost of the system was $36,000. It had a NYSERDA rebate at the time of $4,000. Again, that would be replaced by the utility rebate. So the contract cost was $31,000, and this federal tax credit comes off that contract cost. So it's important to know that you can't take it off the whole cost of the system. It has to be off the contract cost, the amount that you actually were responsible for paying. And there's another little rebate at the time there, but yeah, the 30% tax credit. So that dropped it down to $20,000, the geothermal system. And when you think about how little money that they're paying for their heating, it pays back pretty quickly. They did have to do a couple other things. One thing to think about when you're looking at heat pumps is what's your current electric service, an electric panel. Most homes are going to need a 200 amp panel. And doing a further insulation, sometimes there's ductwork modifications needed. And again, the cost of solar, adding solar in. Again, this house is paying nothing but $20 a month to the utility at this point because it pairs the solar and the geothermal so well. So we've gone through the process of doing an RFP and vetting a number of local installers that we've partnered with for some of them for 4 years now. And so these are the ones we help people connect with. And it's, you can choose whoever you want to work with. We don't require you to go to these contractors. We just help you connect with them as a starting place for quotes. So ACES Energy, they focus on geothermal heat pumps. They also do heat pump water heaters. They're based out of the Rochester area. Breathe Easy is based out of Constantia. They don't do the home performance. They work with Zero Draft on that. They do air source heat pumps and heat pump water heaters and also the hybrid systems. Halco and Snug Planet are combined at this point. They do everything, home performance, geothermal, air source heat pump water heaters, hybrid systems, solar. ACES also does solar. NP Environmental, they focus on geothermal. They also do air source heat pumps and heat pump water heaters. And then Simply Installs focuses on the air source heat pumps. They also do the home performance work also, and the heat pump water heaters. Through HeatSmart CNY, you can kind of get a sense of what people are doing. We've had over 15 homes do installation improvements. We've had over 70 homes install air source heat pumps of some variety. Over 30 homes install geothermal heat pumps, and over 20 homes install heat pump water heaters. So things to consider when thinking about heat pumps, how well insulated is your house? What is your heat distribution system? And of course, none of these are deal breakers in any way, shape, or form. They're design considerations. What direction do the prevailing winds come from? Is your basement finished or unfinished? Or is your heat pump water heater in a closet? Do you like to sleep cold? One of the things that people are used to in our area is setting down the thermostats at night. And that's actually not a best practice with heat pumps. I'll go into that in a minute. If you like to sleep cold, you might want to think about having a zone system, or turning off the air source heat pump in your room, or putting it outside of your room so it heats it when the door's open, and you can close the door at night and have the room cool down. What do you currently use for fuel? What's your current heating costs? Do you want to have a backup heat source, or do you want to go and do a full replacement? You can do full replacements with these systems. And of course, remember cold climate air source heat pumps. So some other best practices, setting it and forgetting it. So the best, most efficient way of using heat pumps is to put it at the temperature that you find comfortable and let it stay there. It will increase or decrease the amount of heat that's putting out, the amount of air that's putting out to meet that temperature setting. When you drop the heat more than 2 degrees, if you set the temperature and you're trying to raise the temperature more than 2 degrees in a given moment, short period of time, you may kick in the backup resistance heat with an air source heat pump, for example. And that's basically just using resistance electric. So you want to try to avoid doing that. A number of households we know that are very adamant in wanting to set back their temperature at night. They basically have a program to increase the heat 2 degrees at a time, like 2 degrees an hour, to avoid that kicking in the heat resistance back up. Remember to clean and change the filters. This is an example of a filter in one of the ductless mini split units. And keep the outdoor air source heat pump units clear of debris, snow, things like that. Here's my contact information. Again, I work with Alliance for a Green Economy, and I'm here to help you make decisions and review things, and as a resource to learn from what I've learned over the past 4 years. One of the things I didn't mention, because I just gave a normal presentation, is that we are encouraging people to enroll by the end of this week. We are in the process of going on a little bit of a hiatus as we plan the next big campaign. Oops, give me 1 second. we've been going for quite some time. And sorry, I need to move this over here so I can see people. And we need some time to replan, retool. So we'll be going to a low mode for a while. But that doesn't mean that the installers aren't there. The installers are there, they're working really hard. So enroll through us and we'll connect you with the installers and we'll go from there. We are going to continue enrollments for the community campaign. So we're partnered with the town of Pompey, town of Cazenovia, village Cazenovia, village and town of Hamilton, and town of Owasco, running community campaigns currently, and we will still take enrollments through them. And with that, we are wrapped up for the presentation. Are there questions?